Hello and welcome to another ramble. Today we're looking at IEB's May 2024 paper 1 question 8a. You are given the following functions. G of x is equal to 3x plus c, so that's a straight line. Y is equal to mx plus c. And f of x is equal to negative 2x squared plus 15x. So that's a parabola because of that quadratic term there. If G is a tangent to F, then calculate the coordinates of the point where G cuts the x-axis. Okay, so first off, I just want to get a visual for myself. So I'm gonna try and sketch what's going on. Yo, what's happening? What's happening? Okay, so we have a straight line. G of x is equal to 3x plus c, so that's a line with a positive gradient. We don't know where the y-intercept is, so let's say maybe 3x looks like that. So that would be y is equal to 3x where c is equal to 0, so it's crossing at the origin. So the story here is that, this line could be there, it could be here, etc. We don't know where C is. So for now, I'm going to just keep it here for now. Okay, then we also have a parabola, and it is a parabola, a sad one, because of that negative coefficient for x squared. And then the y-intercept is 0 because when x is equal to 0, it's going to cancel out all of these terms. We're just going to be left with 0. So it's a parabola. So it could be one like this. Ooh, horrible. Or it could be one like this. How do we know which it is? Well, we can quickly work out the x-coordinate of the turning point, which is given by minus b over 2a. In this case, our b is 15, so 15, and our a is negative 2. So we replace it with negative 2 there. So we end up with negative 15 over negative 4, which is positive 15 over 4. So our turning point, the x-coordinate is on the positive side. So it's the second of the options that I highlighted, so something like that. Okay, I really want this to, okay, maybe let me just draw it on the side and then I'll move it to where I want it to be. Okay, so we know that it crosses there by the origin, so something like that. Another way we could have known is we could have worked out the other x-intercept, right? So we know that f of x, well, okay, or rather what we want to solve is when is this equal to 0, and we can figure that out by factoring out the common x. Then we're left with minus 2x plus 15. So then we know, of course, the one x-intercept is 0. We knew that already. Then the other x-intercept will be, well, minus 2x plus 15 is equal to 0. So then, minus 2x is equal to minus 15, and then you can see that, well, okay, x will be minus 15 over minus 2, which will be a positive number, as opposed to a negative number, which would tell us that the other x-intercept is there. So that's another way that you could figure out horizontally where is this parabola placed, Okay, so now make this even smaller. Okay, right. So the question now is, we know that so this guy is fixed, right? There are no unknowns, well, other than x, but unlike this equation, we were not sure where is it along the y-axis. This one, we know where it is. We know exactly what the graph is. So the only thing moving around is this guy, because we need to figure out the c in order for us to then figure out the x-intercept, where it cuts the x-axis. So essentially, this guy is maybe somewhere here, you know. Yeah, can't really be anywhere else. If we go this way, it's not going to be a tangent, it's just going to cut across the parabola. It's cut it more than once, right? So the tangentness is happening somewhere here. If we go lower than that, it is losing the tangent power. So it's somewhere here. And our task is to figure out what is this c, where is it crossing the y-axis. So how do we do that? Well, we know the gradient of this line is 3, and it will be a tangent to this curve when this curve has a gradient of 3 as well. So we are going to find the first derivative in order to get our gradient function for this parabola. Then we're going to figure out, okay, at which x value does this curve have a gradient of 3? And then that will tell us, okay, this is the x value where this line is a tangent to the curve. We can then use that to figure out the equation of this line and then find the x-intercept from there. So we begin by finding the gradient function for our parabola. So f prime is equal to minus 4x plus 15. And then we want to solve when is f prime, when is the gradient of the parabola equal to 3. So that will be minus 4x plus 15 is equal to 3. Minus 4x is equal to 3 minus 15, which is minus 12. And so we find that the gradient is equal to 3 when x is equal to 3. So this point over here, oopsie daisy, this point over here is 3 and something, right? That is where we're going to have a tangent line with a gradient of 3. So now what we want to do is we want to find, okay, what is the y-coordinate? So we want to find the coordinates of this point so that we can put them into this equation to figure out c. So in order to find the y-coordinate, we are now going to figure out, okay, what is f of 3? So that will be minus 2 times 3 squared plus 15 times 3. So that is minus 2 times 9 plus 45. 45 minus 18 is 27. So this guy is 27. So we can now, so that means g of 3 is equal to 27 as well, because that's a point of intersection between the two curves. So that means 3 times 3 plus c is equal to 27. 3 times 3 is 9, so that means c must be 18. Okay, so that means the equation of g is 3x plus 18. Okay, so now we can figure out the x-intercept. So we do that by solving when is g of x equal to 0. So 3x plus 18 is equal to 0 when 3x is equal to negative 18, which means x is equal to negative 6. And yeah, where does it cut the x-axis? So x will be negative 6 and y will be 0. Yeah, my sketch kind of agrees. At least I got the idea that it's on the left hand side of the x-axis, so hey. Okay, let's see if the memo agrees. So this is question 8a. Oops. Question 8a. Yes, we are in agreement, 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 agreement. Okay, awesome. The memo has an interesting solution as well, which I would like to look at real quick. How do I move you, page? Okay, that looks promising. No, not so promising. Okay, that really looks promising now. Okay, so let's quickly go through the hierdie mense se alternatiewe. What is the solution? Solutie. Uitwerking? Why do I feel like that's me just really taking my chances? Okay. So what they do is they say, well, we are looking for the point of intersection between this line and this curve. And so we can do that by solving the equation f of x is equal to g of x. So that will be minus 2x squared plus 15x is equal to 3x plus c. And that gives us a quadratic equation, right? So we're going to take all our terms to one side. So 15x minus 3x is 12x minus c is equal to 0. And of course, this is not going to give us one answer, right? Because the solutions are going to change depending on where this line is, right? So we could have two solutions, one solution, we could have no solution, depending on where this line is, right? And so that already starts hinting towards how we can use this to figure out when this line is going to be a tangent as opposed to being a secant or not intersecting with the parabola at all. We are going to look at the nature of the roots of this equation. So the question then becomes, for which values of c are we going to have exactly one solution? Because then we know that for that value of c, this line is a tangent to the parabola. Whereas, if there are two distinct solutions, we know that it's a situation like this where the line is cutting the parabola twice, right? Okay, it doesn't really show because I haven't drawn the full parabola, right? So it would be a situation like this, whereas this is the situation that we are interested in, where there's exactly one solution. Okay, so let's find the discriminant, which is b squared minus 4ac. So that is 144 minus, so that's going to be a minus 8c, right? And what we are interested in is when is the discriminant equal to 0, because that is when we will have exactly one solution to this equation. So that is 144 minus 8c is equal to 0. So minus 8c is equal to minus 144. So then c is minus 144 over minus 8, which is, I have no idea. So it's positive. 8 goes in there once, and then into 64 8 times. Right, so c would have, why is there a bracket here? So c would have to be equal to 18, which is what we got before for the equation of this line. So it would be 3x plus 18, and then you find the x-intercept the same way. So that's a pretty cool way as well to approach the question. Thank you for tuning in, and hopefully we chat again another time.